Hello all. Let us continue our discussion on the NodeMCU related things. So we will talk about PWM in the next videos. So PWM, the short form for pulse width modulation, is one of the important interface in embedded systems. So it is used for various applications like controlling the LED brightness, and then in motor control it plays a very crucial role, and then in the regulators to control the switching frequency. So there are a number of applications of PWM. So what we have to do as a part of PWM is basically PWM, as we mentioned, is a pulse width modulation. So what we are going to do is we are going to change the width of the pulse so that we generate the required output. So now what we are saying is, to generate the PWM, we have to control the on time of the pulse, and thereby we are saying a terminology called duty cycle, which is controlled. So what is duty cycle? Duty cycle is nothing but on time by on plus off into 100. So on time is nothing but the on time of the pulse, and on plus off is the total time period of that signal that we are going to pass. So now if you see here, um, for a duty cycle of 0, that means T on is 0, we don't have any pulse here, and you see that 100% there is a low only. And then if you have a 25% duty cycle, you have 25% of the signal high and 75% of the signal low. Okay, and in a 50% duty cycle, you can see here you have 50% high and 50% low. So what it does is, basically when you want to control a specific interface with the PWM, if you want to give more power, you go on increasing the duty cycle, so that if it is 100%, that means continuously you are powering up the device that is connected. Whereas if you are giving 50% duty cycle, you are using a controlled environment, so that your device works, but at the same time it is invincible to the user that you are turning off for 50%. Like example, if you take the LED and you turn off and turn on at such high speed, so that it's not visible to the user, then you save a lot of power, right? That's how the duty cycle works for us. So to perform all these operations, there are two main functions that are available in the Arduino. One is analog write and analog write frequency. So as you see here in the previous slide, two main things are important. One is the frequency and the other one is the duty cycle. So frequency means the T on plus T off is the time period, and F is equal to 1 by T. You calculate the frequency. So at what frequency you want to give the signal, and what would be the duty cycle, the value would be provided in analog write function. So analog write of pin comma value, which pin you want to give output, what value you have to give, what duty cycle value you have to give, that is on analog write. Then analog write frequency of it gives the frequency. Now, as we are talking about the NodeMCU, if you see the ESP8266 datasheet, this is a snapshot from the ESP8266. There are 4 PWM pins, which are I04, 12, 14, 15. These are the 4 PWM pins that come that can be used for the PWM purposes, and the maximum frequency that you can give out is 1 kHz and the minimum is 100 Hz. So as you see here in the previous functions, the frequency can be 100 Hz to 1 kHz, and you can vary the duty cycle as required on 4 pins. If you see these 4 pins on the physical NodeMCU device, so It comes to D2, D5, D6 and D8. So these four pins can be used as PWM on the node MCU as per the ESP8266 datasheet. So let us connect one of the LEDs to these pins, apply different PWM to see how the brightness is changing. You can see here we connected the anode of the LED to D6 and the cathode to ground, and the same wire is looped back to ground. So very simple connection. Now let us see by changing the PWM value duty cycle and see how the LED brightness is changing. Okay, this is the simplest code which you can ever write basically. So now we have seen, right, we connected the LED to the D6 pin of the node MCU, and there's nothing to set up here actually. So what we are just trying to do is we are trying to write the analog value of 200, which is the duty cycle. Okay, so this duty cycle value can be from 0 to 1023. Okay, so and one more point, the default frequency which we have talked about in the PPT. Okay, the default frequency is 1 kilohertz. So if you dump this, so we are just trying to dump the code. If you dump this and if you observe the LED brightness, it is of bit low intensity, we can say. We cannot clearly identify because of the light here. So what we can do is we can just try to show the brightness a bit here. Okay, so now what we'll do is next we'll increase the duty cycle and see what is happening. We are going to change the duty cycle here, so let us include a value of 1000. Okay, and then try to upload this. So while it is uploading, we'll observe the LED intensity. You can see this is with 1000. If you observe, oh, it's very bright. You can see the shining, the brightness clearly compared to the previous one. Okay, so this is how by changing the duty cycle we can generate the PWM value over the analog pin and over the PWM pin and change the brightness of an LED. You can do it for several applications as per your need. Thank you.